Good afternoon, everyone. It's 12 o'clock, so let's get it going, because after this session, the lunch starts, and I don't want this room to be lost in line. That would not be nice, and I also don't want everyone to walk out halfway, so let's get it going. Let's start with an introduction, right? My name is Oscar Ton. I work at BetaBit, and we have some other companies, also VirtualHost and Yield. Yield does software due diligence. Next to that, I get some room, some space to share knowledge, because I love to do that, hence we're here. And with that, we do some videos on YouTube, and we do podcasts. So if you're interested in finding out more stuff, I see some previous guests of podcast here. So know how to find me. Also, if you have any questions. I've been in Azure since it was Project Red Dog, so 2008-9, I think. The initial things before that, I was always a weird developer that also liked to carry around servers and install stuff, and was busy with virtualization. So this got my interest. So from the beginning, I think it had an interest. No one was there yet, but followed it, and while running, we gathered some knowledge, and I survived 4 different portals in Azure, or something like that. And in the beginning, it was also easy to remember all the services that were there. But we're here for one service today, which is a bit more specific. And this service is Azure Functions, and I'm talking about the Azure Functions in the .NET, in C#. And at this moment, if you want to create a new Azure function, you start that. You start a new project in Visual Studio. Of course, you can do it from online, but and you have these options or more. It's all Azure Functions. It's all .NET. It's all C#. How did we get here? Well, that's the story for today. To look at the future and future tech, but we heard also this morning, we need to know our history. Azure Function was released in 2016, and in 2016 we were still all in framework. I'm calling it full framework here, but .NET Framework officially. And Azure Functions was an evolution on web jobs. How many of you here know about web jobs, still use it? Everyone, almost. Web jobs was a small add-on side thing within the app service, which used to be called Azure Websites, to run some background processes mostly. So it did timer functions, and it could pick up some queue messages, and you did some handy out-of-process work for your front end. But it was pretty interesting to do that. And then in 2016, they came up with the serverless functions as a service platform, and there were multiple clouds doing something around that, and multiple incentives there. But what they did, and that's where our history begins, is take most of the web jobs code that was running behind it, most of the bindings and triggers that were already in there, moved it to Azure Functions and gave it a serverless platform to run. So if you continue, we had, of course, we went the same time frame, because 2014, 15 was all over the place, and then we had in 2018 Functions was supporting .NET Core. So we had a V1 and a V2 at that moment. And you stayed on the V1 if you had .NET Framework workloads. And of course, we evolved, we get some new stuff behind the scenes. We don't really see what is going on, but we're evolving with the .NET Framework. It's also going really fast. Yesterday, .NET 8 Preview 2 came out. Doubted about creating an ad hoc demo this morning, but that's not mess up my installation for the other demos. But this evolved. But for a long time, this V1 was also still necessary. If we go back to the basics, what are the Azure functions? And we're looking at the, I would almost call it old school functions here. Functions consist out of a few things, and this was the promise. It had a trigger. How does it start? And with functions also introduced HTTP as incoming, like the web jobs didn't really have that because it was already in that service. But as a trigger, something invoking the function, and that can be a timer, but it can be a message. In this case, it's a queue trigger. It had input bindings, so pulling stuff that already exists, and it can be from some web service or it can be from any other resource. Some extensibility was also possible there already. And we have output bindings. So in this function, I created some data or manipulated some data and I could throw this on. The biggest promise of the whole serverless thing was scaling back to zero. So this combination of really bursty, small tasks that weren't like big batch jobs, so really sparkled, at least in my surroundings, people starting to invest, well, not by too much cost, but invest in thinking non-batch job, thinking event-driven in smaller things, taking non-primary workloads like sending emails and stuff off-site and just throw something on the message. It became really reachable also for small, even private projects to create something that had a cost of almost zero. With this, we also got our first complicated billing system that did micro billing per seconds per gigabyte and a really tiny amount. So it was really hard to predict. But we evolved a bit further into that we had multiple hosting options. The first one, if that's possible, is still the consumption plan. So it runs somewhere, there's compute. That's really the power of the cloud, of course. Use everything, every corner of and every VM somewhere. Just we have some processing power here, so why not waste it? So there was the consumption plan with the micro billing. But if you needed more dedicated and more control, we at some point got the premium plan, and premium plan got some proper burst scaling. So if you want to like instantly spin up 50 instances of it with 7 gigs or 14 gigs of RAM, like it could do that, you pay the price. That's not the micro billing, I would call it. You can run on a dedicated plan. It's basically the app service plan running under app service. You can also host them in there, and you can divide and make denser workload if you want it yourself. Then we have the weird one out, the app service environment, really isolated, secure offering, which also is an app service, but also used here. So it's the same as a dedicated plan, and we can run it in Kubernetes if you're having Kubernetes running anyway and you want to program them. So this is the background of Azure Functions. The weird story of the split model begins here. When .NET 5 got released in 2020, we had the promise beforehand of one .NET, because we were 4.8 is going to be the last .NET framework, and after that, all your new workloads you should build in .NET, because we also dropped the core at that moment. And that promise was interesting, but in November, app service, you could just push .NET 5 to, and it was a short-term release, but from day one, you could host that workload. If you have some shared code, and you were moving around a lot of stuff, you found out that in Azure Functions, it wasn't possible. Azure Functions was still v.1, and it wasn't supported. In the next year, and I think this is in December, they told the story what they would plan. So, what was the idea? Is to build a new model. And why would you build a new model? They needed a new model because the time frame of the new release cadence, short term, long term, meant that they needed to put so much engineering work in getting the library model working. They need to build it for every specific version again and again and again with all the downstream dependencies. And there was actually a problem by now, because coming from web jobs all the way here, your functions would run in a dynamically loaded assembly in a runtime that's already there. So you're running an environment that they control and that you control. That also means that you get the version of Newtonsoft JSON in there that was already running. And I think a lot of us know how fun it is to solve JSON conflicts over 20 versions. So this was already a problem. Going forward, it's going to be even more problem with so many revs of .NET. They decided to introduce the isolated version. The isolated version wasn't anything weird. It wasn't new because all the other non.NET workloads were doing that. It ran a backend worker, it ran another executable process, and it started communicating with that to put the trigger data in, and trigger data, the binding data out, and all those things. So they kind of like, well, let's re-engineer this, put it side by side, and from the next versions, we will do it like this. So, short, the class library model is the old one, and the isolated process model is the new one from there. The problem with the library model is though it's bound to the .NET lifecycle and it's tightly coupled to whatever they offer you. You cannot break out of that. You cannot run preview versions in there. Would be a problem. The isolated model they also wanted to keep on par. You don't want to lose too much if you are rebuilding, but rebuild seems always like a good idea. It's hard execution because everything else is also moving. They wanted a similar programming model. They're depending on the other the plane that was already there, where the other non.NET languages were running. But because we're missing the tight integration, we also pulled out all the rich integration, rich types. So durable function wasn't there. They wouldn't even know how to solve it yet. And a lot of people were pushed in that direction, like do those kind of saga patterns, do it like that. So you had anything running in there, they didn't see any future there. But also smaller things like getting a message in from service bus and not having access to the underlying receiver to requeue the message or something like that, because it's abstract. It was just gRPC between the backend and your process running, and it just communicated with basically dumb objects. So problems started to exist, and people were a bit hesitant in how to use this. So I think it was sidetracked for a while in a lot of companies, like we'll do this when it's done. This was the plan that was introduced. So we were, back then, we were just going to .NET 5, we just had a release in .NET 5, and we knew like, well, we're gonna get a .NET 6. And the in process, if you want to use durable functions and the rest of the bindings, the rich bindings, from .NET 7, they should be in there. And then we can move over. So .NET 7 or .NET 6 would be the launched long-term support version of Azure Functions in the in-process model. So there was an article last year. So we are here. So that seems like, well, we should pay attention to this. You know what Azure plans? They change. So we have the same plans, but we stripped off the numbers now. We don't really know where it's going to land and when it's going to land. We might still connect to the initial plan, losing the old in-process functions in .NET 8. I don't want to be too much of a negative here, but I think .NET 8 will have full support for the old version. By the looks of it. We're not there, we're not feature complete yet. But the biggest question for us is, of course, like, when, what to use. What to use when we rebuild, when we're starting something new. Should we, if we're doing a refactoring anyway, should we pick it up? So that's interesting for us today. But basically what they said, if we're feature complete enough, the next long-term support version won't support the process model anymore. That basically means that if we will, looking at the progress, still have it in 8, I don't know if anyone knows by heart, but I think we will not have a problem for the next 5 or 6 years in support land. So don't worry, don't run home and rebuild everything. It's not completely necessary yet, but still interesting to check out the differences in the model. So differences they introduced in the new model is that you lose dependencies, so yay, you get full control of those. That also means that, it's the bottom bullet by the way, that you can start and run any version of the .NET framework that you want, from .NET or the .NET framework, you're correct. With that, it's now GA to run .NET framework in the isolated process. With that, they are also stopping GA on V1, finally, or support on V1, because the .NET framework for isolated is now on support. But also means that the preview of .NET 8 that got out yesterday, you can install it and run it and see what happens. Mostly that, but basically you can do that. The output bindings, we're going to explore those a bit. They are different, mostly, and I'll let you form your opinion how you like them. New features, there's middleware now, which we know from ASP now. We've got first class dependency injection, also the way we know it from ASP.NET. There was an option to do DI with some attributes hook into the startup process somewhere and do it from there. But basically the older functions were mostly the template in .NET. You knew it up, you got a static one, you needed to work with the bindings mostly. And we got cancellation tokens now. That's nice, so they get injected if you define them. There are a lot of tiny differences. What if you want to migrate? Small thing, but very first time we find the second one. The attribute of actually defining a function, like it used to be called function name. You're looking at that and you probably loaded still a bunch of old libraries and things still was highlighted and nothing was there if you ran it. But that was basically because they renamed that to function. Yep. That's something you won't pick up the first time looking at the code. The bottom one is the old version of the startup you could do, which I just said, if you want to do some startup, some configuration, app configuration or dependency injection, then does this work? Yeah. Then you could put this hook in. It was a bit of a weird construction, but then you had two hooks to actually go through before the rest of your functions started. Now it's the right part, so it's basically a host builder. And you can do DI there, you can do all kinds of things, and you just run the host like you do in ASP.NET. So that's interesting. Let's see what I'm doing. Time for a small demo, I think. Before I cause death by PowerPoint. So start with this. So basically, in the other screenshot, you saw the old functions, and I'm gonna go through the new ones. This is the house builder you just saw on the slide as well. So you create a house builder, and there's a default version in there. You can also strip this out, do everything yourself in the order you want. If my mouse cursor is dropping down, it's because this thing is. Yeah, didn't think about it. That's not what's happening. And we have configure services, so we can do dependency injection here. We can also hook in the builder, do something with app configuration, all kinds of things you want. That's pretty straightforward. Ignore the comment without code, it's part of a small demo that I want to do. So first what happened if you out of the box, newed up a .NET 7, this is .NET 7 Azure Function Isolated. That's this one. If you want to add a new function, you can add a new function. You get the dialog. It's pretty familiar if you were using the old Azure Functions. And in this case, just for the demo's sake, HTTP trigger is always easiest to demo with. Zoomed it a bit too much, and you lose some context. So you basically get this as a function. So again, this defines that it is a function, will be discoverable. There's an HTTP trigger, which defines that it will expose itself as a HTTP path. The request data is coming in here, and you can do some other things as well there, but let's do that later. if you want to respond, this by the way, this HTTP request data is yet another version of something specific for Azure Functions. Also in the older models, there was always something that looked the same as we're used to in the rest of the platform, but slightly different, sometimes annoying. We will see that this is one of the heavier parts of feedback at the moment, and they're thinking about rebuilding this again, so that action result comes out of it and stuff. It's a hot topic, like it will go on. That's my prediction. .NET 8 will still have full support. So to create a response, you basically hook into the same channel that was open in the gRPC channel in the background coming in. You don't need to know this, but it's happening in the background. It creates a response object attached to that thing, and you return it. And that means, in this case, you returned welcome to Azure Functions. I think you all believe me that this works, and we should try anyway, because something that shouldn't fail is always easier to debug. Yeah. Wait for it. Network. So to run out, it will discover functions. We see there are a few in there. In this case, this is the one I just created, and go to console. So what we can do is just get it. We kick off the function. Oh, there's some breakpoints here. It will write the string back. You see here the outcome. Go to Azure Functions. And this is actually the running function that will log whatever it was doing. So, basic thing works. I was saying you can use the request object and make a response object. But basically, this thing is actually doing all kinds of same things, because if you would want to do, for instance, this, and you create a record, and let's get the most obvious version. It's a person item. We have first name in there, and of course we have the last name in there. Visual Studio understands demo code, so it will complete it for me. And if I would just throw everything away and would just return, person. Oh no, I don't even have to do this. New versions, new features. My mouse is falling again. Fun. See if I remember my name. So if we run this, what would you expect to happen? I didn't identify anything myself. Let's read the breakpoint. Didn't identify anything myself to specify what should return. What would I do if I build a platform like this? Well, in this case, it will return a JSON version of that thing. Just serialize it, throw it back. Pretty simple to make some function. What you do see is that it does work, but it doesn't look fully designed because the content tab is thrown back. It's not content JSON. So be aware that even though these things work, and there are a lot of more weird tricks in there, if it's not in the documentation, don't count on it. It might change. But you do see the simplicity of basically of the model. You can do these kinds of things. So what we wanted to do is prove the dependency injection, and I think, I got 2 versions here. It's awesome to do, of course. So in the configure services, you get the IO service collection with it. You can add some service in here, and of course you can also use the IO options pattern. In this case, it's a bit of a weird section binding. But then basically you can go back to your function. Also, all these templates, the file new templates, are now non-static anymore. They're just classes. They always have a constructor, so they're really pushing you in the direction to be able to do some DI. So in this case, I could do some service, and I can do something like I options. And now I can remember what the thing was. Example config. Example config. This is an option, and we would wire this up here. And config. It's always also hard to type when a lot of people are watching somehow. Am I the only one having that? No, right? Value. Yeah, let's create a typing field like this. So in this case, put a breakpoint in there. The DI works like you would expect. Console. Yeah. Okay, by the way, I love this Quake mode terminal in there, Windows backed in. It's cool, somehow. So it goes through the constructor, some service got in, and of course I have some config value here from the config, and it fell back to hello from the local settings JSON. The original as a default, if I didn't set it, it would say hello from default value. So this is kind of working as expected. If we go one step further, what we said, we were also saying something about middleware. That's why I commented out some code here. So in the, in this case, configure the configure step. Configure defaults also sets up a lot of stuff you probably need. In there, you can do a use middleware. And the middleware, if you never used it, it's basically a pattern where you need to, in this case, implement this interface, and that's not necessary in HPNet. It has an invoke function, and it gets the next, and the next is the next middleware, or basically your function in line. You change it. So the order that you push them in, it will execute. If you never worked in ASP.NET with middleware, this is pure magic. If you did, it's exactly the same. So basically, in every function that we run now goes through this middleware, and it's interesting because we get, and you can also inject that in every function you want. You get some functions context, and there's a lot of stuff on that object. There's a lot of stuff about the execution, the runtime, data coming in, so you can think of all kinds of fun scenarios to do this. So I'm going to set a breakpoint here, and I'm going to stack some middleware. Because what if you like in middleware? In this case, or you can do your own authorization system. Everyone should write their own authorization, you know that. It's a joke. But for instance, we can also write a piece of middleware that suppresses things you didn't think about and give the same result. That is a bit more sometimes security things, like not throw out our 500s and show what where you can attack us on, but just write them in logging. In this case, we just do a try-catch of the step, so you actually your middleware pipeline, basically also your function in the end. And if that goes wrong, we say, well, it failed, but here's a 200 OK. We also love those. But I need to add it, and what we don't want to do, because I'm hooking up in this middleware, I need to show you, I'm hooking up, I'm assuming that we have HTTP request data coming. So I'm assuming this function is HTTP function. If it's not, this is triggered everywhere. So how to plug this in? You use your, for your middleware, you use a use when construction, and this is very pretty. I'm going to show you. So I'm going to place it behind the other middleware. So the other middleware is next, is going to be this one, and that next is going to be the function. But to only filter on which pieces of middleware you use when, yeah, that's nice. And you need something in there that returns Boolean. So it will use that middleware. The way you discover this is actually an XP trigger is not a thing of beauty at the moment. This is actually in the Microsoft documentation on the site that you can do it like this. I think they can make a shorthand somewhere in the library for this, because this feels a bit odd. But anyway, to test this, we can, in our function, we should just, let's use this. We should just throw new, some exception. I don't care what kind of exception. So if we're going to try this, I'm going to set another breakpoint or not. No, it's already here. So we're going to start this up again. I'm going to try this again. Let me see. Press. I'm going to kick it off, and we will go through the stack. There goes my mouse. Right there. We're in the first breakpoint. So the first middleware, the example middleware is kicking off, and it will hand over to the next delegate. Then we go into our setup. So it's already wiring out of order here. This feels weird. Wiring the this breakpoint, wiring up the class in the background. We're going to throw the exception here. Oh no, it makes sense because I have the breakpoint in the other one later. So it did the await. That's why I went into the function first, but it crashed there. So we're catching this exception. Now, in this case, I'm going to plug the request data out of the channel and create a response directly. So you're going one level deeper. You see invocation first. We're going one level deeper. The moment you start using those middleware constructions, you need to know what's going on in the background. You will look into those invocation details because otherwise I create a timer or I get a message in there and I will check out is this an HTTP function. So the trick is to use that use when, so that before it wires up the class where your function is, it already knows ignore it because it's not HTTP or this is HTTP or whatever scenario you want. I promised you something about output bindings. Because we're looking mostly at triggers now. So in no, this one. Yeah. This. So if you want to have an output binding, in this case it's a timer trigger, so it's easy. So this just runs an execution, runs on some schedule, basically you can define a blob output, and it uses my default connection string to write on the function to /last run write something in the date. And my return value is a string, so that will be in this case the body of the blob. You can put a string in there, you can do all kinds of things, and it will just hook it up. So it's very simple, very straightforward. Yes, if you have one output binding. The next part is to get multiple output bindings. If you're, for instance, working like one-on-one like this, you timer or a message, you know, one output binding is just handing off, doing some logic, handing off. It's fine, super easy function, powerful. But if you have an HTTP call, you also want output, but you also want output binding links, but also return of your invocation. So how would you set that up? Well, in the older model, you had, for instance, if you wanted to output some messages, you had IASync collectible, IASync collector, what is it called? Something like that. But you injected in your method, you injected all kinds of objects where you could just write your data for your output binding. In this case, your return value is by default your output binding. That's different. So, let me see here. This one here. So, if I want to do this, and this is an HTTP function, for instance, but I also want to write on that blob that we just saw. So we need a different way of response because how to define that on function level. So basically what you need to do, say basically, because it's really weird, is create a specific class. Just gonna come with output value, don't have any good name for it. Got some cheat notes here. HTTP out. Oh, how many did? Sorry. Yep, that. So I have some output, but I also want to write something to the blob. And this here, and let's just make that a string, not to torture myself too much. And we'll out, and I'll do that. And I'm going to put the attribute in here. So the attribute we normally would put on the function itself to return, we put here. That means we need to do something here at the function. Basically, I want to, at some point, output this type of Ctrl-C copy. And Paste. Want to output this type, so we should new this up somewhere. Output value. I want to, on output, write something to the blob property. Hello, not too else. Want to write something to the blob output, and on the HTTP output, I also need to do something, but that basically means that I need to do this. And need to write something on there. No, not that one. Write a string there. No, not asynchronous. Also I. That's touch. So, and then I need to return this output. So this is basically the model you get if you want to have multi-outputs, which raises a discussion for me using this stuff every day. Getting for every function specific class with these kinds of output, and if you have, for instance, an output with messages, and you have maybe sometimes somewhere in your code, so you want to output a message, somewhere in if, don't use if statements, creates complexity, we don't want that. But if you want to do that, for instance, then you need some output, and you get a list of enumerables where you push some value on. You also carry that all the way to the end of the function and output it. It feels weird, it is a bit weird. And then basically for me in this model, my opinion, the triggers and the input bindings all good. The output bindings, why don't I just use the dependency injection, get a server bus client in there, or get any other client in there? Because those SDKs are around, you can decide it for yourself. So in a lot of cases, except for the really simple input pass on functions, which is super powerful, of course, these output bindings are a bit odd. But judge for yourself. I call them specific. Let me see it. Look at the time. So we still have something to go. So that was demo number one. So if you want to pick up your existing functions and start migrating, you will encounter a lot of tiny differences. The multi-output bindings we just looked at, acquired taste. Yeah, you know my opinion. The non-rich binding, so not being able to pick up the underlying connection and do something with a message or whatever, can be a bit of a hassle. Here it is, the AIC collector, which I thought was an awesome pattern, is not there. What I also mentioned, HTTP model enhancement. So if you want to track it, it's that issue on GitHub. It was suggested from the core team, it's like, maybe we should do this. And it describes a new HTTP version that had IASync result, or the default ASP.NET object types that we're used to. So we can go full force on everything new. So we don't want ASP.NET, we just want a few HTTP functions, but the exact same model there. And if we're doing that, and you migrate first to every weirdness that's there now, might be a bit of a waste of your time. But definitely know it's out there, and look at it. In the older model, we also had something called retry policy, and it was pretty new actually that they introduced that. You could put attributes in different functions, like, oh, we try this a couple of times, if it doesn't work, super handy. It's not in the code, so you cannot do it from code. You can also only define that somewhere in a host JSON, because that part of the runtime isn't in your code, it's not available, so you need to tell that to the underlying runtime. So you can define some things there in the JSON of the host.json if you're depending on those retry policies. But a bit of a waste. Like I was looking at demos, I was like, oh, this is going to be cool, and they've taken it away from me. Use poly. Yeah, but that's the thing. This model feels a bit like, it's basically just a small version of ASP.NET if you're doing anything, especially with HTTP. So why would you? Sometimes. Still the backend code and stuff with especially working with service bus, still super powerful to have this. and to implement this, because it makes you make simple code. But if you're migrating, the suggestion would be, for me and the ones I did up until now, create one next to it, lift over function, because all the groundwork you need to redo the code. If you're, let's throw out all the dependencies and then pull the new ones in, it will take you a long time before that thing runs, come with all your code out, start working it. So I would say create a new project, just pull everything in. The bottom, yeah, that's my quote basically. Durable function wasn't in there, but wait, a month ago, we saw this one. So we are thrilled to announce a durable function support in the isolated workers out now. So that means they did some work there. And indeed, it's there. Slightly different, as we're used to. The good thing is that they are now also depending on system text JSON, but we have more choice, yay. So next to the function based with the attributes, we can also do a class-based model. That means that you inherit one of their objects, one of their classes, as an activity or whatever, and then it works like that. So a cool code cell to explore. Don't know if that is, it's definitely even less migratable. If you look at the right side, if you want to migrate, there you can find, it's also from the documentation, you can find what the renames are there, because also what happened, got new names, also not to confuse, that were in a new version. And we're missing something, durable entities is not there. If you were using over durable execution, you were storing some data here and there, you might were using that, but it's not there at the moment, and the call HTTP async is not there, which was powerful, but basically it's not that hard to do that, call yourself in a normal activity function. If I look at the time, I can do just a really small demo of this. I'm gonna rush it because we're hungry. So this one's called simple durable, just to prove that it's there. It also said all the packages are stable now. If you look at the packages, they are stable except for one.
The durable task.
Now the durable task generators, I haven't checked it this morning, maybe it's there. With the GA, that one wasn't there. Basically, it's working based on code generation, and they are still working out if that's necessary, because they might have a model that works without code generation. But at this moment, they're using this. You write all your code, but in the background, if you start to compile, lots of code gets generated for you to make this durable function work. Makes sense, but I thought it was funny that everything was stable, except the one thing making it work. But it's once it's built, it's also supported. So it's not you can run in production and you have support. If you look at a function, let me open it. A simple version. Zoom out a bit here. So again, function implementation. I've got here one HTTP trigger, and it you require as an input the durable client. You get a client. You can start your execution there. And in this case, I want to say, well, handoff, start, an invocation of an orchestration. And that means that this will run straight through the HTTP function. We'll kick that off. We'll do a lot of storage magic and queuing in the background. And then the orchestration starts. In this orchestration body, I do a few things. As an example, I create a lot of tasks and I do a when all. But it reads like the normal async model, but it's actually working a bit different. Mm-hmm. You should be, like also in the, if you ever worked with durable functions, know that this thing gets executed multiple times. Because what it's basically doing, the orchestration starting, it's starting to, it will kick these things off, and it will, in the awaits, will actually wait there for a bit, but just kills the function. And we'll restart the function. So don't do any HTTP calls or I/O in here. That's really horrible. So what it actually does is actually on the background, gets the IDs of all those running tasks and wait until they're there. So that basically means that even though they are starting these all at the same time, they won't, because I introduced some nice randomness here, they won't be done at the same time, and they will run in parallel but with different times. So it will run through the orchestration multiple times until every task is done, and so until it's done, it will kill the function here again and again and again. So to demo how this actually works, I'm basically doing a logger with the input going in, but the output is the input. So that means you are an awesome crowd is actually what should be printed here, because it's true. If I start this thing, it's cool to look at the logger. This builds for a while. So this is building. This function, I'm just going to kick this off. So in this screen, I'm going to just kick it off. What you see happening here is that the orchestration, starting orchestration, restarting orchestration, starting orchestration. So you see that it's running through that code body constantly. We also see that the activity logging is like, are you a crowd awesome? So it's a bit Yoda-ish. But the end result, we have the tasks in order executed all, and it says the result is you're an awesome crowd. So in this case, we can prove that Azure Function is actually a thing again in Isolated. Let's recap for a bit. Strike button. Here's my clicker. So what to do? And support .NET 6 is still officially, no, it's not officially true, and it's probably not gonna, probably gonna be tweaked. Don't worry, but do think at the model, because it is kind of complete. If you're doing a migration, rebuild, if you're starting anything new, definitely look into it, because maybe all the DI and all the native stuff actually frees you up, or losing the Newton soft dependency will really help you going forward. There are still some dependencies or some problem with cold start, which is always already a problem on serverless, but we now have a bit more. The saying on Linux is running a bit faster, kicking off a bit faster, but especially the ready to run option, so it does a full compilation and will help you in the cold start. If you're heavily depending on the HTTP model, the refresh is coming, so I would definitely look at that and wait until the discussion is at least finished. They decide to do it or not to do it, but it would be a waste of time to rebuild everything and then find out you have another weird problem. I'm guessing, I'm curious about their support there. If you want to know more, I created a simple URL list. QR code, never scan QRs, it's not secure, but you can. Those are basically the top, or the top one is basically the GitHub project. They're building this whole worker in the open. You can contribute to it, you can contribute to the samples and documentations if you want, but you can also pull the samples and documentation to play around with it. If you have any questions, find me later. Find me on any platform at Oscar van Tol, LinkedIn, Twitter, Mastodon, whatever is there out there these days. I have some site where I sometimes write some things, and it might be fun to check out our podcast, because we have awesome guests from Dennis to Scott Hansen. So thank you, have a great lunch and a great day today.